Hi, I'm Jared Haywood, AI/ML specialist. I've worked on the Amazon SageMaker team for the past 2 years, building new features and helping customers get more value out of their data through machine learning. I'm based in Salt Lake City, Utah, United States, but cover no-code machine learning globally.
And hi, I'm Davide. I'm a specialist solution architect for artificial intelligence and machine learning here at AWS. Been working in the company for 4 years. I was previously in France, and now I'm living in Brussels, in Belgium. And I'm covering the business in the Benelux, so Belgium, Netherlands, and Luxembourg. But I also help customers all over the globe whenever they have a challenge with low-code, no-code machine learning tools and features. And one of them is actually one of the topics that we're going to talk about today, isn't it, Jared?
Absolutely. So with that being said, we're definitely going to be diving into how you can generate these machine learning models without writing any code. What does that really mean though, Davide? Like what's the no code part of this?
Well, the no-code part of the machine learning is actually the capability, giving actually the possibility to everyone, regardless of their background, whether they are PhD, whether they are students, whether they are developers, whether they are line of business owners, to actually get some insights, to get some knowledge from machine learning models without needing to have this background of science and math that usually people like data scientists, personas like data scientists, they usually have. So the idea is that everybody should be empowered with this tool and with this technology, and we try to achieve that in the simplest way possible without removing the code from the equation, using no-code tools.
Okay, cool. So if I have, what you're saying is if I have a spreadsheet with some historical data, I might be able to predict or explain patterns that are happening.
Absolutely. If you have any kind of historical data, or you have information about if you have any customers, any of your customers, or really any information that you have in a spreadsheet, and you have something like a target that you would like to predict, for example, sales into the future, if your customer is going to churn or not, anything really. And as long as you have enough information to feed to the algorithm, to the machine learning model, then the machine learning model will actually learn from those patterns and try to drive predictions out of those patterns as well whenever they see new data.
Okay, so kind of based on what happened in the past, what's going to happen in the future, right? And so you mentioned a couple of use cases: customer churn, sales forecasting. What are some other problems that people could use this to solve?
I'd say that the imagination is the limit, Jared, honestly. Here, there's so many different use cases, and we work with so many customers across so many different industries that it's really hard for me to tell you, hey, you should only solve like this, and that challenge. We've seen use cases ranging, again, from sales forecasting, warehouse prediction, or, for example, even in the healthcare and life science business, readmission to the hospital, supply chain, on-time prediction for deliveries, for example. And the more time goes on, the more we found the more we find new use cases that we can solve through machine learning in general, and in specifics with no code machine learning. So yeah, imagination is the limit.
I love that. Sounds like can solve basically anything that I can put in a spreadsheet. So
Yeah.
with that, everybody has customers. Every single business has a customer. Can you show me how to solve customer churn using Canvas?
Absolutely. This is what we're going to talk about today. So I just have the right demo for you. I'm going to show you how to solve a problem with SageMaker Canvas. In the specific, we're going to solve the challenge of customer churn, meaning understanding whether a customer is actually going to leave us or not, and try to avoid that possibly. And we're going to do that in just 4 simple steps. So we're going to import some data. We're going to create a machine learning model. We're going to analyze the performances of said model, and then we're going to use that model to actually understand, hey, how are we going to run this prediction, and what's the likelihood that my customer is going to churn or not. So I'd say that without further ado, we should jump into the demo.
Great, let's do it.
Let me give you like a little bit of an overview, so that you know what you need to use about SageMaker Canvas so far. The main components of SageMaker Canvas are actually two parts. So you see here on the left, you have two buttons. One is called models, and a model is actually what's going to help you solve your challenge, right? It's going to let you solve with some performances, whichever kind of problem you might have, whether that's a churn, it's a sales conversion, it's a stocks prediction, anything you really have your mind set to solving. And
So
then you
these
have
are
your
so these are
data.
models that you've already created.
Yeah, I've already run some experiments. You can see I talked about Canvas to my customer all day long. So you can see that I've run some example. Here you can see regression for supply chain, meaning predicting in how many days a package is going to get to my door. I've done some prediction about churning. We're going to see that in a second. And I am also using a sales conversion data set to understand if a marketing campaign is going to work or not.
Awesome.
But the very first step is always to have a data set. So a data set is essentially your spreadsheet in this case. You have a CSV-like file, so you have your spreadsheet where you have columns and rows, many different information inside there, and you will need to provide that to the service so that the service can start actually driving some intelligence from it. So let's go ahead and actually build a model together. What I'm going to do is I'm going to create a new model, and I'm going to call this churn SageMaker Fridays. So hopefully you guys don't churn from SageMaker Fridays. And the very first step that I'm going to do is that I'm actually going to, as you can see here the four phases of a SageMaker Canvas demo or a SageMaker Canvas workflow. The first one will be to select a data set. So what I'm going to do is that I'm going to actually import my data set from here. I have my data set available. I'm going to actually find it here on the side. There we go. And I'm going to just drag and drop it here into the UI. So what's going to happen?
Super simple.
Yeah. And you can already see what this looks like. So you already have a preview. You can see that this is a churn prediction again, once again, use case. This is a synthetic data set. So it's a fake data set about users from a telecommunication company, so a telco company. In fact, you can see where the customer is from, how long it has been our customer, the area code, his phone number, international plan, minutes, daily charge, how many calls it has done so far, if we contacted them or not, if it has reached out to the customer service, anything. And then finally, we have the most important information, which is actually our target, meaning what we are trying to predict here. Is my customer going to churn or not? So you always need to have this target.
So basically what you're saying is we're trying to use, it looks like these are mostly features about how the customer is using their cell phone plan or their telecom plan, and then using that. So we're essentially saying based on how they use it, who's more likely to churn or not. So can we identify some patterns in how customers use their phones to see how those might impact if they're likely to churn?
In a nutshell, that's exactly what a machine learning model does. It tries to analyze this behavioral data in this case, because this is the behavior of our customer or any kind of data that you actually provide, and tries to match it through some computation and calculation to our target variable in this case, which is if the customer is going to churn or not. So from historical data, you get to actually to your target variable, which you need to provide ahead of time. And this one can be provided, for example, by your analysts if they already know if a customer has churned or not, if it's still a customer or not. It can be provided by your line of business owners, for example, just because they already know also this kind of information. So there's many different kind of sources that this can come from.
Great. And what if, Davide, I mean, I saw that you pulled this from your local computer and just dragged and dropped it. What if my data was someplace else? What other places can I load data into Canvas from?
That's a very good question. So let's take a look at it quickly. There are three other sources at the moment available in SageMaker Canvas. One of them is Amazon S3. So it's essentially our storage for data, our file storage system. And if you have buckets or if you have colleagues that have worked and have made a data set available for you through an Amazon S3 bucket, then you can just go ahead and select it from the list of S3 buckets that you have. You can connect also to warehouses. So if you are a Snowflake user, for example, you can connect through your secret to the Snowflake cluster or through username and password. And very similarly, you can also connect to the Amazon Redshift cluster, being the data warehouse that is available directly in the AWS platform. Also can connect through username and password and IAM access. So you have those four possibilities here.
Okay, so there's a number of options that I can and paths that I can take to get my data here, even though even though we only showed how to upload from the local computer.
Yeah, and always know that if you have multiple sources, for example, you have one dataset which is available locally and one dataset that is available on S3, and another one that is available, for example, somewhere else in a Redshift cluster or in a Snowflake cluster, then what you can do is you can actually join those sources. So you can combine them so you can make a bigger data set and you can combine information coming from disparate sources and from disparate people so that you can drive as much knowledge as you can.
That's really powerful because for a lot of analysts, all of the data that they would want to use or attributes don't necessarily exist in the same place. Like here, we were looking at how they used the cell phone plan, but maybe in other cases we would have additional data sets, right? About what their engagement was with marketing content or web analytics, things like that. And that's really cool, Davide, that we can kind of bring that all together here.
Yeah, and let me show you also how you can bring some knowledge, some intelligence out from this. So let's go into the second step. Let's select this data set. And you can see that here, a SageMaker canvas is trying to load something. So what it's actually doing is really trying to analyze a little bit what your data looks like. So you can see here that we chose our churn file that I uploaded before, and it started to give me some information. I'm going to take a deep dive into what this is in a second here and why this is important. But where I really want to focus is actually to make you understand how SageMaker Canvas solved this problem and what is the very first step that you need to take in this phase for the building. And it's actually highlighted here in the top left corner of the Canvas UI. So select the column to predict. As I was saying before, you want to predict specific values. So you want Canvas to be aware of what it is trying to predict. In this case, I have the full list of the features or the columns that I was showing before. And in this case, my target is going to be churn, meaning is my customer going to churn? Yes or no? And SageMaker Canvas automatically understand with kind of model problem you're trying to solve, meaning machine learning has many different kind of problems, right? You can solve what we call as binary classification, two-category model here, essentially saying, will a delivery be on time? Yes or no? Will a customer churn? Yes or no? And this is our challenge, and Canvas correctly automatically inferred that. But it could also be different kind of problem. It could be a multi-class classification, meaning, for example, will a delivery be early, on time, or late? So you can see multiple categories here. It can be a regression problem. So how many days will it take to a customer to purchase again? Or it could also be, this is very interesting and very used every day, it's a time series forecasting. So imagine that you have historical data about your sales or the inventory available in your warehouse, and you would like to predict future values for that. So you can also solve this challenge through SageMaker Canvas and through the AutoML technology that powers SageMaker Canvas.
It's pretty robust. Seems like there's a lot of different problems that you can try and solve using Canvas here.
And the most important part, and the most beautiful part, I'd say, the most powerful part of all of this is the fact that I don't even need to know how the algorithms are working behind the scenes, because that's where the AutoML magic comes from. So AutoML means automatic machine learning, and it's the idea behind which we don't really need to know what is the science behind things, what is the math behind things, what is the algorithm that is powering SageMaker Canvas behind the scenes. All we need to care about is just understanding what is my target, what is the problem that I'm trying to solve, and then ask Canvas to just generate a model for me. And Canvas will do the magic for you. We'll select the right model. We'll try multiple models actually. We'll try different values for those models because there's some knobs that you can turn for each of those models, and Canvas will do that for you. And we'll do so in, first of all, very quickly. You already see that here we get already a metric. I'm going to get into the details of what that is in a second. And most importantly, without me having to write any single line of code. The only thing that I wrote is the actual name of the target column, and that's it.
So okay, that's really awesome, Davide. I mean, there is a lot going on behind the scenes, but I don't need to know about it, and that's really comforting that I can just kind of move through this, and know that I'm going to get some of the best results out that I could potentially get, just because of how it's taking some of those best practices and applying them automatically. Is that right?
Think of Canvas exactly about this way. So it's a mean to get you to value from your data. It's not about the technology. It's not about what's lying underneath. It's not about the code that you're writing. It's all about the value that you can bring from your data through machine learning, so that everybody can just go ahead, fire up Canvas, provide their own spreadsheet-like data, and just go ahead and fire up a new training and use that to generate prediction.
Awesome. So when I look at what this is kind of surfacing to me right now, it's telling me that it can predict churn 95.6% of the time correctly, based on using information from all the other columns in this data set. Is that?
That's exactly what's happening. So behind the scenes, Canvas is studying essentially your data. What's happening is that it's trying to read between the lines of what those values of, for example, the email plan are, how many messages have been sent, or for example, how many night calls has been done by your customer, and tries to see how the changes in this value actually reflect whether a customer will finally end up churning or not. Think of it as a sort of a decision tree behind the scenes that for you Canvas will build, saying, okay, if I analyze this pattern and I see that it's going this way, then my customer is more or less likely to be churning versus one that has, for example, more night calls versus less international calls, etc., etc. So the mathematics behind the scenes is a computation that it's applied on all of those values and on the distribution of those values, so that you can actually get to the target. And some of those features, or some of those values, might give some more or less information about how how to get, let's say, to this target variable of churn. And that's what's loading here, and it's taking around 2 minutes. It's called the feature importance, meaning some of those information can be more important with respect to another when we go into the prediction. And one of the nice thing about Canvas is that whenever you create a new model, you are already actually building towards this, not just creating the accuracy, so not just computing the final value, saying I predicted correctly 95% of the time, but also trying to understand, okay, why am I making those predictions? What's impacting my prediction? And you can see actually here an example. So the more we go into the night calls, or the more minutes during evening calls, for example, the more it has an impact on the churning, versus, for example, information such as the phone number or state or something or area code might be information that is actually not giving away a lot of information. It's not very useful. So we might even think about dropping this information, changing this information as well.
Well, and Davide, that's kind of on average, right? So if I was to look at that or say it a little bit differently, I don't necessarily know if more night calls are good or bad yet, but I do know that, hey, the night calls on average are making the biggest difference to whether a customer is likely to cancel or not.
That's exactly the way that it works, Jared. You're completely right. So that's the impact. It has more impact. It doesn't mean that more calls means more likely to churn. It just means that the value changing in the night calls value actually has a bigger impact and a bigger effect on the final value of whether the customer is going to churn or not.
Awesome. And this is just from the preview model. What do I get a little bit, what do I get differently when we do a quick build or a standard build?
So You're already going very fast, Jared. I know you know already Canvas, but let's give a little bit of an overview as to what are those words that you just mentioned. So the idea is that when we're trying to build a model, when we're trying to create a model, then what's going to happen is that we can choose essentially two options: quick build and standard build. So the quick build what will actually do is that it will train a model, or rather multiple models with multiple hyperparameters, multiple values, and it will take around 2 to 15 minutes. It's a quick build because it's faster than what it would be if we were to build a huge experiment, a big experiment. But it's perfect to create those kind of quick builds if you want to first of all analyze more the performances of your model, so understand how it behaves way more than just taking a look at the metrics here, for example, the accuracy and the column impact. If you want to know more about how your model behaves, you can go into the quick build. And then you also have the standard build. The standard build is a much bigger experiment. It's a much wider experiment. You have many more models that are being tested behind the scenes with many more hyperparameters, so many more different values associated to those models. In fact, it takes longer. It takes around 1 hour, 2 hours, according to the size of the data set. It can take even up to 4 hours if it's a very big data set. But the idea is that it will try so many combination of those values that at the end of the day, it will give you the best possible model. So if you're trying to strive for the best performance possible, definitely go for the standard build.
So there's a little bit of a trade-off between speed and accuracy, where quick is going to be faster, but maybe a little less accurate, and standard's going to be maybe a little bit more accurate but take a bit longer.
That's exactly how this works. In fact, the idea is that in the quick build, you do that more likely just to go ahead then and test, first of all, the metrics and the performances of your model, analyze a little bit how your model works, and also to test the prediction of the model. So if you want to use your model inside the Canvas application, then you can just go ahead and fire up a quick build and use it directly there. In about 10 minutes, it's going to get trained, and then you can use it to generate your prediction. While if you really want to build the best model that then you're going to put into production, or rather that you want to share later with your data scientist colleagues or with an ML engineer or with an ML ops engineer for them to put into production, then what you want to strive for is the best performance possible. And in that case, you will need to go with a standard build.
And I saw that you didn't hit either of those yet. We've only done a preview model. It seems like that can actually help iterate pretty quickly. Maybe there's features or changes that I want to make before going and running a quick or standard build.
Yeah, absolutely. So, for example, you can also do a little bit of data preparation and data cleansing inside SageMaker Canvas. I prefer to call it a little bit more exploratory data analysis, because the idea is that you want to visualize a little bit the data distribution, understand if there's any outlier being a value which is something that we do not expect might be noise to our system.
It's
Maybe you want
anomalous.
it's an anomaly, exactly. You need to be careful whether you want to keep the anomaly given the business knowledge that you have. If you're trying to solve fraud detection, then anomalies are good because those are the things that you want to try to predict. But for example, you might have some anomalous points, something very strange that might not make a lot of sense. It might be let's say, a bug in the data that you received, or something which is so rare that it does not bring any knowledge, just noise. Then maybe you want to replace it, you want to change it. Or just like in this case, we saw that information such as state and phone and maybe international plan as well, or area code, they do not provide a lot of information. They are just not very relevant. So what I can do is that I can just remove them. I can drop them from my model building. And in fact, Canvas will generate a recipe for me. In this case, I'm going to drop the information that I think does not make a lot of sense. In this case, I'm just going to keep those ones off. I'm going to keep the rest just because I feel like that. And in fact, when I drop those
It's
columns,
another experiment.
it's another experiment, exactly. So the first experiment will be dropping off state and phone. And you can actually see that Canvas tells me, hey, you have made those two changes. Maybe you want to see how this impacts your prediction. Let me just go ahead and update the preview model that I have. And while this is building, let me also talk to you about what other kind of transformation you can do. And trust me, it will be much faster for Canvas to train a model than for me to go through all of those different options. So you can extract information, for example, from date and time. So if you have something like a date where the customer signed in and you want to extract information such as the month of the year, the quarter, or something like that, you can do it easily with the push of a button. You can do some data filtering, removing rows in your data set, whether they have some missing values, whether they are outliers, whether they are past a specific standard deviation. You can also replace specific values. So if there's something that you don't want to change, maybe you want to change a value from yes to one and from no to zero, or you want to really change anything, replace a missing value with something else, you can
Or
just go ahead and
even
do it here.
even looking at this data set, maybe state I have a combination of the abbreviation and the full name and want to easily change California to CA.
That's a very good call out. We see that all the time. Actually, many customers have information from different sources. So what they want to do is they want to normalize this data or standardize the data to the same kind of format. So at that point, what they can do is they can use either remove those rows if they believe that they don't provide any knowledge, any additional knowledge, or maybe they just want to replace those values. So they can just go ahead and change that. Have you noticed, by the way, that we improved our model already? We just drop into columns with 2 clicks of a button. That was very fast, and that already improved by 0.4. So 0.4% is actually not bad for just removing some noise from the system. So yeah, I would call this a success.
Awesome.
So what I'm gonna do now is that I'm gonna let it run. It's still building the preview model. I can go ahead and fire up, let's say, what I would do as a next step would be to either create a quick build or create a standard build. In this case, I'm just gonna go ahead and fire up a quick build. It's gonna take from 2 to 15 minutes, and it's gonna train a model. Actually, it's gonna train some models behind the scenes, test some hyperparameters, and get a model out. But since it will take 15 minutes and we don't have all the time today, I've actually already done one for you. So we can take a look at what it looks like here.
Awesome. Before we jump into this model, Davide, how much data do I actually need? Like what's a good data set size for machine learning? Is there too much or too little?
Well, machine learning is very experimental in the way that it works. So it's very hard for someone to tell you, hey, you always need like 1,000 rows. You always need 10,000 rows. The more complicated your use case, the more data you're going to need. But if you provide too much data, then you can provide also some noise into the system. So you might make it more complicated than it is.
So
We
okay.
always suggest.
Well, so more complicated the use case. Like, so meaning if I'm trying to predict human behavior versus something like that meets the laws of physics and nature, like maybe determining what kind of flower it is based on petal length, etc.
Well, of course, it will be kind of tough to provide like a threshold for me for this kind of problems. But let's say that smaller problems, easier problems can be solved with even like 500 rows or 1,000 rows. So I would say that already a good measure would be 1,000 rows and about 10 features for solving easier problem. Solving more complicated problems, they will require a lot more data. In this case, you can see that we are using, for example, 20 columns and 5,000 rows. That could be also a good unit of measure, and you can see the performances here are pretty good. But again, keep on experimenting. The good thing about Canvas is that you can just update your dataset, provide a new one, and quickly experiment to see how providing more data will actually impact the prediction that you have and the performances of the model that you have.
But it sounds like I can get started with a few hundred rows in most use cases, and up to hundreds of thousands.
Absolutely. You can already have some results from starting from 500 rows or even less than that, depending on the use case. So absolutely, do go ahead and try that out with the even small data set that you might have.
Great. Well, now that we're looking at this model here, Davide, how did it perform? Is it good?
So there's big number on the top left corner of the screen, which says 97.86%. So that's a pretty big number, which means it's a pretty good model. So
And
generally, this is one of the accuracy predictions. So this is one of the metrics that you can see. It's a composite measure that provides you information about how correctly it gets our model. So in this case, 97.86% of the time, we correctly predict the churn column to be the right value.
so essentially, out of every time that I threw the dart, if I threw 100 darts, 97 of them hit the target.
I would even go as far as to say 98 of them.
Round up. I love it.
And if you really wanted to know how that happened, so this throwing of dots, if you really wanted to look at the details of this, you can actually see here in the analyzing tab and in the scoring tab, you can see how it does in terms of prediction versus actual values. So you can see that all the times we actually tried to predict, let's say, for 556 true value that we actually had, 538 were correctly predicted to be true, and only 18 that were supposed to be true were predicted as false. So in this case, we only have 18 errors, let's say. And the same applies for false. In this case, from 476 to 472 were correctly identified as false. And in this case, the rate of false negatives in this case would only be 4, which is pretty good. So you might want to be careful. You might already have some knowledge whether you want to try to go for a model that has very low false negative versus very low false positive, because they might have a different impact on your business. It might be more costly to have a customer that will churn and you predict that it will not churn, rather than to have a customer that has churned, but we did not detect that. So you kind of want to play around with those values and try to see the one that kind of fits better your line of business.
Davide, let's back up a step. Where are these numbers coming from? How do I know that this is actually how accurate this model is?
So what happens behind the scenes is that as part of the AutoML technology, what we will do is that we saw that before. We have like 5,000 rows, and what Canvas will do behind the scenes is that we'll take a part of that. We'll take 20% of this data, and we'll use that to test the performances of the model that it has trained on the rest of the 4,000 rows. So it will take 4,000 of those values, it will train the model on those patterns, and will use the rest of the 1,000 values to do what we call as a validation of the model. Validation of the model meaning that we already know what the actual value should be. We try to generate a prediction, and we try to see if this prediction matches with the actual value. So this is where this accuracy comes from, and this is how we score our model.
So it's almost like the same as a student in a classroom where they're shown example problems and learn principles and generalize how to apply them. And then, at the end of the semester, there's a test where they don't know the answers to those questions, but the teacher does.
Exactly. So think of the validation as a more of a follow-up exercise for the student. In that case, the student might already know the answer. Actually, he doesn't know the answer, but the teacher does have the answer to this. So what will happen is that we test the student against the knowledge that he has acquired so far and validate his knowledge. So we have like a score sheet, and at that point, we just check, hey, were the response is correct or not? And then once my student is ready to go to the next step, so they are ready to go out into the world, then what they can do is they can actually go ahead and do the prediction. So that's the inference part of things. So it's just like saying to a student that has tested in the world, that has done some validation in the world in the school, okay, now you can go out in the world and try some things for yourself. In that case, they will be prompted with all the information. They will be facing some status, some situation, and given the situation that they have, they will try to generate some prediction out of it. In this case, this is what we call a what-if scenario, meaning that what we can do here in the Canvas UI, in the prediction tab, is that we can generate simple prediction and we can change values inside each of these, let's say, these features, and see how they impact prediction. So for example, I don't know, let's try something. Let's say that a customer has been our customer for a long time, for 5,600 days. Let's see how this impact our prediction. You can see that that showed a little button that says update. So it will try to generate a prediction. saying that, for example, this is 99.96 likely that the customer will not churn. I mean, if it has been a customer for a long time, then it kind of makes sense for them not to be, not to churn actually, so not to leave us.
Now,
In this
Davide,
case, yeah,
if you earlier on the analyze screen, you showed me the feature importance a little bit. Can I use that here to kind of help inform my what if at all?
absolutely. So let's take a look at what it looks like. So let's take true as the value that we would like to predict, and we're going to use evening charges. So for example, you can already see here what is the impact of each of those features as on the final target, meaning that the bigger it goes, let's say the bigger the more we have the charges during the evening, the bigger the impact it has on the prediction itself, meaning the more it goes towards being more likely to be a true value. In this case, you can see that there's a sort of correlation here. So there's you can imagine here a line that cuts from this point all the way to the top right point, and you can see that the more evening charges, the more likely will be that we have an impact on the true prediction, meaning that it's more likely that a customer will churn. So we can already see that we have this sort of impact. In a very similar situation we might face with this value, for example, night calls. If we have a lot of night calls, for example, here, you can see that the value tends to be closer to the false value rather than to the true value, meaning that the more night calls, the less likely should be for a customer to churn. So maybe we
Or
want to
or
try that.
inversely, like well, actually, let me put that together. So on the left side of that panel, you were showing that, hey, evening charges is on average the most important variable. So if I was to drop all of the other columns, I still might get a half decent model, right? And then on the right of this, I'm seeing the direction. So I'm not just saying, hey, on average, it's the most important. Now I'm seeing, hey, as evening charges increase, it increases the likelihood of churn being true, or conversely to that, as evening charges decrease, the customer is more likely to be retained.
That's exactly correct. And you can see one of the nice things about Canvas is that you can test this with all of the features that you have used during your training. Some might have a very clear pattern, like we've seen right now with evening charges. Some might be more generic, with, for example, in this case, as a true or false value. And you can see that through a box plot, what is the standard deviation, what is the impact on that prediction. So you might want to go ahead and play around a little bit with those values to see how they actually impacted the likelihood of churning or the likelihood of retention.
That's awesome. And it can also, I mean, if we were to take that back to the what if, now I have a couple of variables that I know generally are pretty impactful. So if I want to make a big impact on the prediction, maybe those are what I want to kind of try and tweak.
Yeah, so let's give it a try. For example, one of them was evening charge, if I recall correctly,
Yep.
and the other one was a low value for night minutes, if I'm not wrong. Let's try. Let's go ahead and try with evening charge and see how that impacts our prediction. You can already see that this changed a lot. So the fact that we had a lot more charges during the evening, as we expected from the analyze tab before, you can actually see that the new prediction is much more likely that my customer will churn, and it went from 99 likelihood to retain to 90% likelihood that it will churn. So we might really want to be careful about the way that we charge customers, given the fact that customers that are charged more during the evening are more likely to churn in this case.
So this could give me a couple of insights. I could either, reach out directly to this customer who behaves this way, or I might try a couple of A/B tests to try and change that behavior.
Imagine that you are part of the marketing team and you want to launch a new promotion where you say, hey, if you are likely to churn at this point, what we're going to do is that for the calls that you do in the evening, you're not going to get charged anymore. So in that case, the value for night charge will go to zero. You will update that value and you will see that you can retain your customer. you are much more likely to retain your customer at that point. So you can use this kind of information together with your business knowledge as an analyst and as a line of business owner to actually drive this campaign and make sense of the data and retain your customer, which is the value that we are all striving for.
That's really awesome, Davide. And what about like sharing these predictions, or how do I kind of let other people know, hey, there's this cool new thing or finding?
So first of all, there's two things that we've seen being done with customers. So one of the things is that you can actually download the generation, the prediction that you make, so that you can share them, for example, in a PowerPoint presentation or in any, let's say, business case that you want to actually provide some knowledge to, powered by machine learning. So in that case, you can actually download the chart, download the prediction as another CSV file, so another spreadsheet, and use it, for example, downstream with your dashboard visualization tool or with anything you might need. Another alternative is that now that you are satisfied with the performances of your model, you can actually ask your data scientist. So if you have a fellow colleague, which is a data scientist or a machine learning engineer, and you would like to ask them to put in production your model, then Canvas allows you to collaborate with those people. So if you want to collaborate with those people, all you need to do is you just hit the share button here on top right, select the model version, because you can create multiple version, of course. And then what you can do is that you will generate a link, and then you can take this link and send it to whoever you want it. It could be a data scientist, it could be a machine learning engineer, it could be an MLOps engineer, and they can use the rest of the ecosystem in AWS to actually build some knowledge. For example, in this case, they will be prompted with all the results, all the computation, all the artifacts, all the models that have been generated by Canvas. They can pick them and use them as part of a downstream process, whether the downstream process is, for example, putting it into an application, sharing it with other people, automating it as part of a pipeline, or maybe just telling you, hey, you got to work on this again because maybe it doesn't make sense, or maybe you need to improve the performance a little bit more because we want to do better. So yeah, you can go back and forth and try to solve the customer challenge that you have and provide as much value as you can to your customers.
Now, Davide, you said something pretty important there, in terms of all of the assets, artifacts, etc., will be there. So down to a code level, down to a Python notebook, everything that's being done in Canvas can be reproduced by somebody who knows how to code.
Absolutely. While for the analysts, or for the people using SageMaker Canvas, this might sort of look like a black box. It's actually a white box, we like to call it, because at the end of the day, when you're sharing this model with SageMaker Studio, every transformation, every data processing, every recipe that was built, every data set that was split, every parameters that was generated, every artifact that was created as part of the process of SageMaker Canvas will be completely available, will be available in the form of a Jupyter notebook. It will be available directly as a downloadable link in Amazon S3. And any data scientist or any machine learning engineer can just pick those up and put them into production very easily.
So I guess the only thing left, Davide, is how do we get started?
That's a very good question. So, well, first of all, what all you gotta do is that first of all, reach out to your local administrator, or if you are the administrator itself, go access Canvas, create a SageMaker Studio domain, open up the application for SageMaker Canvas, and then just let yourself be helped by SageMaker Canvas. We have a nice help button here, which will walk you through a 1 minute tutorial for each of the steps that you've seen today. And it will actually walk you through in a tutorial fashion every single step that we've seen today, creating a model, uploading a data set, and just going ahead and playing around with the data. And if you're looking for a specific workshop, or if you're looking for any specific club, well, first of all, reach out to your account team at AWS. They are always very happy to help you. We, Jared and I, are very happy to help you. Or if you want to do it in a self-service fashion, there's a lot of workshop that you can access as part of the workshops.aws page. You can just open up workshops.aws, give it a second to load, and you can search here in the workshops for Canvas. If you are searching for Canvas here, you will see a SageMaker Canvas immersion day. You can open it up, and you will see that as part of the SageMaker Canvas immersion day, you actually have 7 different labs with 7 different industries solving 7 different use cases. So you can just go ahead, pick the one that you prefer, pick the one that you like the most. Today we've run together through the customer churn one. So if you want to go ahead and repeat the exercise on your own by downloading the dataset and testing it out, you can just go ahead and do that. Or if you are in another industry, just choose the one that feels like it's more appropriate to you. And as Werner Vogel would say, just go build.